This is going to be part 2 to section 12.6 and 7, which is the Lewis structure. And just like there are in lots of things in life, there are exceptions. So there are exceptions in Lewis structures, and some exceptions to the octet rule include boron. Boron tends to form compounds in which the boron atom has fewer than 8 electrons around it, and it doesn't have a complete octet. For example, if we look at boron trihydride, hydrogen has 1 electron, and there are 3 of those total, for a total of 3 electrons here. Boron has 3 as well. So we add those together, and we have 6 electrons. So when we place those hydrogen around the boron, you notice that the hydrogens are fine with the duet rule satisfied, but boron isn't. Boron doesn't even have an extra set of electrons out here that are unpaired, and there's a total of 2, 4, 6, not 8 around boron. So boron's an exception to the octet rule. This is what boron trihydride would look like. Molecules containing odd numbers of electrons, like nitrogen monoxide and nitrogen dioxide, we can have some problems with those as well. So draw a Lewis structure for each of the following molecules. Let's look first of all at BF3. Alright, so fluorine has 7 in its outer shell, and there are 3 of those. That's a total of 21 electrons I have to take care of, plus boron, which is 3. So I'm going to come up with 24 total electrons. We're going to put boron in the center. We're going to single bond it to fluorine. Fluorine, we know, has to have 8 in its outer shell, so let's go ahead and put that out there. And then we'll count our total number of electrons. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. So you notice that fluorine is satisfied. They each have 8 around theirs. Boron, on the other hand, doesn't have 8. It only has 6, but I have taken care of all 24 electrons. So here again, boron trifluoride is an exception to the Lewis dot structure of having the octet rule filled for boron. Let's look at carbon dioxide. So we know that oxygen has 6 in its outer shell, and we have 2 of those for a total of 12. Carbon has 4, and we have 1 of those. So we have 16 electrons, 16 electrons total for us to take care of in carbon dioxide. So carbon, probably double bonded to oxygen. Let's see how this works out. So we have carbon 2, 4, 6, 8 around carbon. Oxygen, let's make sure they have 8 around them. So we have 2, 4, 6, 8, 2, 4, 6, 8, and we have a total of 16, 2, 4, 6, 8, 10, 12, 14, 16 electrons total. So carbon dioxide is double bonded, and it's actually a linear compound. Carbon tetrachloride. Pick up the pen instead of the highlighter. So chlorine has 7, and there are 4 of those, so there are 28 total. So we have lots of electrons we're dealing with. Carbon has 4, and there's 1 of those, so 8, 9, 10, 11, 12, so we should have 32 electrons. Let's put carbon in the center and come off with a bond around 4 different bonds, so 4 pairs of electrons. And let's tack our chlorine out here on the outside edge. And then let's go ahead and make sure, now we know that carbon has its octet rule met. Let's go ahead and fill chlorine's octet rule as well. And then we'll go back and see how many total we have. So we know that all the chloride ions are filled with their outside shells are filled. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. So this is the Lewis structure for carbon tetrachloride. And our final one is going to be the cyanide ion. So we have nitrogen, which has 5 in its outer shell. We have carbon, which has 4. And we've gained 1 because it's a negative 1. So the total that we need to have is going to be 10. So we put carbon single bonded to nitrogen. So let's make sure we have the octet rule filled here. So we have 2, 4, 6, 8, 10, 12, 14, way too many electrons to deal with. So let's see what happens when we take out a couple sets of those and throw in another bond and see if that helps. So we still have the octet rule here, the octet rule here, 2, 4, 6, 8, 10, 12. Still 2 electrons we need to get rid of. So let's do this. Get rid of this, get rid of this. And go ahead and throw a triple bond. So we have 2, 4, 6, 8 around nitrogen, 2, 4, 6, 8 around carbon, 2, 4, 6, 8, 10 total. So we've met our number of 10. And then it's an ion, so we're going to put brackets and the charge on the outside edge. So that's how we would write cyanide. So that's going to finish up our Lewis structures with 12.6 and 12.7, and the next lecture will begin molecular structure in 12.8.